So let me show you QEMU with 24 cores. It's going to be loud. So hyperthreading means 2 threads on one core sharing resources. I used to think it would be noticeably slower. I used to think if you had some cores hyperthreading with 2 and some with 1, I used to think you would get a big difference. QEMU has slow disk access, or normal. Anyway, so I made a really valuable tool. I might add this as a built-in to the it's so useful, I think I might make it built-in. Rate cores. It measures context swaps for 10 seconds. That's probably more than enough. What? Wait a minute. Something really strange has happened. What? Maybe my CPU is not hot. That has to be what it is. I was getting about 3940. No, I was getting 36. What the hell is going on? Oh, but look at core 0. Poor core 0 is struggling. So maybe, oh, this is probably using up CPU, of course. What the hell is going on? You don't understand. This is strange. Maybe it's not calibrated. It's a core 0 sleep. What's that? That's done with the... So the reason I made this command is exactly... Now if you divide... With TempleOS you divide jobs yourself. If you divided evenly, you would really want to exclude core 0. You know what happens? I'll tell you what happens. Core 0 ruins... Oh, QEMU is okay. Oh, I don't know why it's so fast. It has a throttle so that when it's hot, it's slower. Well, that looks pretty... Well, that's pretty good. I used to think the glitch was not my fault. Now, so here's the issue. Core 0 has all the extra work of, you see, one core. one core has to draw the background to begin with, the horizon, that's core 0. One core has to draw the letters, those are kind of odd. All the unusual things have to be done by core 0. And what it does is it assigns a job in addition. And so I don't know what the maybe I wasn't using the other cores and it got cool. How, I don't understand. This just is weird because they were definitely 3940. This is really weird. Now it could be the full screen. Oh, that's it. My resolution of my I'm an idiot. Wait a minute. It shouldn't do that. So I changed the resolution of my screen in order to do this screencast, but that shouldn't change. That should affect core 0. I think we're seeing a calibration problem or something. It has to be. I did a sleep instead of a reading of a clock. I just assumed the sleep was accurate. Let's go ahead and %12.6 F. This is, I don't know if this is any better. I could do HPET. I don't think this is going to matter. This is, what clock is this? This is HPET, or, shit. Okay, where did it go? Oh, there it is. So 10, oh, I'm a genius. Okay. Well, that's not going to work. I'm glad. It can be a nightmare when you don't know what to trust. So it took 13 seconds. I'm glad I was not a fool. A fool would have said, my CPU got way faster for no reason. I'm not a fool. Okay. Now there's no, I have no way to translate this into clock speed. What it is it's context swaps per second. So I don't know if that's measured. I forgot. It might be measured at boot. 24 cores, 2.9. I think it's measured. I don't think I got it out of the. Sometimes you can. No, that's measured. That's measured, calibrated by HPET. Does everybody know HPET? HPET. You know it's a nightmare. 10 years ago, VMware didn't support HPET. And so I was running natively and in VMware. And what do you do? Because what do you do about that? Then you have to make it use HPAD if it's there. In a nutshell, that's what the insanity of the clusterfuck is what I'm gonna fix as king. So there's some people at OS Dev who will tell you, well, just if it's there, use it. If it's not there, don't use it. You have no idea how many clocks there are, and some are better, some are slow to, some take a while to access, and some are accurate, and some are not there. I guess that's not true. Anyway, so there's one clock that oh, I used to have really nice global variables, but then I got ashamed and I put them into I used to have really simple names. I only had maybe 150 global variables, and it's not going to grow. I was foolishly forced to get rid of counts. It used to just be jiffies, and now we have to do counts. Jiffies. So this is a just a memory location. The scheduler has a 1 kilohertz cycle. As a matter of fact, it doesn't preempt anymore. Anyway, as a matter of fact, I could slow it down. There's no reason to have it 1,000 if it's not doing preemption. We don't have time slices anymore because I got rid of preemption. Why did I? Well, first of all, let's bail out of this. QEMU is ghetto. It's VMware is a disgusting company. I went for PC speaker support, and they did everything to conceal the answer, which is they used to not support it. Then just recently, so I have 24 cores, and so I went to I have 24 cores, and they have a maximum of 16. So I don't mind honesty. What pisses me off is when you conceal the answer. So this makes me run around, and it wastes my time because you're not honest with me. Now that fucking pisses me off. VMware's a scumbag company. They are absolute dirt. They're the scummiest company. Maybe I should use my divine authority. And God said to replace Windows with wine. so we can go ahead and disband the company Microsoft. Fuck them. They've done enough. They're a scumbag company. VMware. So VMware. So let me just show you this. Setting the number of cores per CPU. It's like really sleazy. It's the fucking sleazy. Why can't you just admit that it doesn't do more than 16 instead of wasting my fucking time? But now I understand how this company works. They're sacks of shit. It's not even hard to fix it if you wanted to. They fired their anyway, somewhere in here is a real sleazy. They try to hide it. It's like one time I bought a used car and there was a little dent in the hood and the salesman tried to lean over to conceal it. It was really pathetic. Anyway, so like, it's like, you think I'm not going to notice the dent in the hood? You think I'm not going to notice that it doesn't support 16? You're trying to conceal it so that I don't notice? No, you're just making me furious, and you're wasting my fucking time. You got to think ahead, you motherfuckers. Now, I don't like Marxists. I don't like communists. It actually makes me happy that I paid money and this one is 5 times faster disk than QEMU. I can compile. I can do a make all, compile 50,000 lines in 6.9. It used to be or 0.69. Let me just show you what QEMU. It's like 2. And when I do the long compile, so this matches my worldview, which is professionals are professionals. So that makes my world. I'm a conservative. I don't like Marxist. I was at Ticketmaster when sued by Pearl Jam, and I was laughing. Anyway, what a fucking disgusting. Is that like homo or what? Pearl Jam. That is fucking disgusting. I didn't know when I was younger. I didn't know that Iron Maiden was homos. As recently as Queens of the Stone Age, I didn't know they were homos. I don't know how you could not know that. I think I figured it out. With a name like Queens of the Stone Age, you should know they're homos. So, anyway, so what I am really, I'm glad I've kind of run out of things to do, and one thing to do is to get familiar with unknown hardware, and I spent a lot of money on this. I got a Xeon. I'm really happy with it. I got 64 gig, which is hilarious. But anyway, it's only by, I can see the future when I work with this. I'm 10 years ahead, or not 10 years, I'm 3 years ahead or something. So I can see how it works. So yeah, this is what I thought. Yeah, it's 3, 4. Now I guess I need to fix my calibration. Son of a bitch. How are we going to do this? Well, let's just... So we want an accurate clock. HPET is high resolution accurate. I guess it doesn't drift. I don't know. Is it calibrated? The one I trust is the real-time clock, since it doesn't lose time. But that takes forever to read. I think I finally... T sub S is what I'm telling all my sheep. They're my little sheep. That's what I'm telling them to use. I think that's what I did. It checks if you have an HPET. And if you have an HPET, it uses HPET. HPET is just reading a location. I don't know if it's full speed access. I don't know about memory. VGA memory is slow. I don't know. I guess I could measure how fast it is. I don't care. And then if you don't have an HPET, it reads a sys timer. So this is the cluster fuck that happens when you have flexibility. The CIA does this fucking on purpose. This branching shit, the entire, everything is cluster fucked like that. So, okay, so T sub S, I guess, T sub S is most likely HPET. So if T sub S is, why is it T sub S? That used to be sample, what? Time in seconds? I don't know. We have a naming protocol. Variables start with lowercase. Functions start with uppercase. That's why oh, this is a function. I don't know. Fuck. Did I just say that? Is that fucked? What did I do? That is my... It's a function. How come I didn't say T sub S? T is period. Big T is period. You can't have big T. I started with just, I think, I might have had just T. I could swear I might have had just T. Oh well. It has to be perfect, so if it's wrong, we have to change it. It's really easy to change it. I can change it this fast. That would change it, but big T is period. I don't think we... Anyway, we actually do have subscripts. And as a matter of fact, the variables in the compiler recognize subscripts as part. You can have subscripts and labels. Control Shift P. Okay, let's remember that. So we could say T, Control Shift P, S, Control Shift P, T sub S. Why don't I do that? I guess I could. The question is, You know, I did start using pi and theta. I like those. I used to have alt. You remember the old DOS where you said Alt 222 or Alt 225 to pick an ASCII, a screen code? I used to have that, but now I changed it to Control Alt A, and you can get an ASCII. You can get a screen code. And so you know what I did? Alt 1 is, I made these, I made Alt 1 into pi. Alt 2 is theta. Alt 3, 4. So I just, since those are the ones I use, I put them there. I made it a user, so you can put your own. You remember the old days when they had function keys? People used to make macros. You remember when they had keyboard templates? They used to have documentation on the keyboard. You put a, the old days. Now they don't. Now the keyboard is not as common. Anyway, so let's get back to what we're doing. So this is easy to fix. Sometimes I like elegance. Anybody can fix stuff by making it ugly. Some people don't even have shame for making it ugly. Hello? Hello? That's weird. Some people don't have shame. Hello? 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 Okay. Whatever. So, like for example, notice how my cores are out of order. Someone's gonna say, why don't you put them in order? You have to admire the beauty of this little program. Anybody can fix it by making it ugly, but it's beautiful. So calibrate. Son of a bitch. That ruins everything. Now I have to divide by the, now I have to scale it. I could use less than 10 seconds. That's kind of extreme. 5 seconds is good. Hello? Hello? Okay. I guess that's what we're gonna do. Fuck it. Anybody can fix it, making it ugly. Some people are real cocky and they turn out shit. I try to keep my line of code count to a minimum. They, little arrogant motherfuckers, no shame. Any genius can make it complicated. Takes a super genius to make it simple. Hello? Yeah. Okay, cool. Bye. Okay, so what should I call this? Count. Okay, I could allocate based on M. That's a little bit better. If dynamic is better, then I try to do everything dynamically. I try to do everything dynamically. It's a global. That sucks. In this case, it's. Oh well, fuck it. Sometimes you just got to. At least I used to have all my global variables were tiny. MP count is the multiprocessor count. And I do everything dynamically. I have almost normal people use arrays, but I do almost everything dynamically. You'd be surprised. Almost nowhere in my I'm exaggerating, but almost nowhere in my operating system do I use arrays. I use dynamic or fixed length buffers. Almost everywhere it's dynamic. Okay, so this ruins everything. Global count GS no equals I. Damn it. It was beautiful. Now we just give it I64. It was so beautiful. Okay, so the reason we don't increment is because it's faster. If it's a local variable, is going to be a register. As a matter of fact, yield is a big yield is a function call that dwarfs this operation. But why throw money away? Anyway, okay, so you could argue it's one less line of code to increment the count, but we don't want to do that. Anyway, you have to, when you're doing multi-core, you have to keep them out of each other's way, as a matter of fact. You know what? As a matter of fact, I'm ignorant. A cache line is 64 bytes, and you can do a lock. I made a lock. You can do a lock, read, modify, and write. You would think I would know this, but I am not certain that accessing the same cache line is safe. But I'm gonna do it anyway, because I do it and get away with it. You know what's funny? One time I tried to program with independent caches when I first started Multicore, I thought that each core had its own cache and they were not tied together. It blew my mind when I learned that they kept the caches synchronized. That is amazing. But anyway, if the caches are not synchronized, it's impossible to write programs. You can do certain programs, maybe multiplying scientific matrices, but everything else, if you don't have shared caches, it's impossible. I'm giving you some wisdom. If you ever sit down to try and write a program for multiple processors that don't share cache, that is fucked up. And it was at that, when I realized that, I made a policy. TempleOS is strictly for single socket multi-core. I am not doing multi-socket multi-core. I assume that they don't have shared cache. Right? How could they do that? No, they don't have shared cache. If you don't have shared cache, breaking a job, like when I say breaking, this is what I want to use multi-core for. Like graphics, it's a good parallel thing. If you did not have shared cache, that would be impossible. If you try and sit down and get work done, it's impossible. Anyway, so we have to do T0. Should we be accurate? Might as well. I could do it at the wrong time. Okay. T0 equals TS. We might as well do it. If you can keep it easy to understand. Okay. Oh, you know what? What caused? I should research what caused. I should research what caused the failure. Why did the sleep go over? Maybe it did not go over. Okay. You know, every once in a while a core can get stolen, and that really messes up real-time multi-core. Okay. You know, one time I was hoping to avoid, okay, so I have 12 cores, okay? I have 12 cores. I'm going to take a break for a second. I have 12 cores, and I have 24 cores. I have 12 hyper-threaded cores. So when I was trying to decide, first I thought my first choice was 12 because if you do 16, then you have some hyper-threaded, and I thought those would make it much. I thought those would be the limiting factor when you're doing real-time multi-core. If you had cores running half speed, that would be terrible, and you'd rather have 12 full speed than 8 half speed. So at first, that's why it was really important for me to do this utility. This. Okay. The other thought was, well, what about Windows? What about Linux? Would I be better off if I was not sharing a core with Linux? So if I did 8, then perhaps Linux would use a core, and I would have cores that are 100% free. So I thought 8 might be good. But I got my answer today. The right answer is 16. Now, some of this stuff Intel made it. If they hadn't, sometimes Intel makes decisions and we don't know what the alternative was. Anyway, so the reason I wrote this is no bullshit. When I make my own benchmark, I know what I'm talking about. And what this benchmark is the scheduler doing integer operations to it saves the registers and loads the registers. Really simple concept. So what yield does is it saves the registers and loads the registers. It doesn't change memory maps because we have a very simple operating system. So mostly it's just saving registers and loading registers. Anyway, so when I do my video games, I'm doing integer operations. I guess I'm not doing arithmetic. I was really proud. I was really confident that this benchmark was what I wanted. Because I do integer operations. I don't really, anyway, so I was really confident that I was getting exactly what I wanted for a benchmark. Anyway, so because I don't, what they like to tell you is SSEMMX doing big array multiplication, and that's bullshit. That's not what I want. I don't, you know, I might multiply a 4x4 to project a point, but it's not something I do over and over. And SSEMMX, that's just not useful for what I like to do. I'm trying to make a Commodore 64 and a modern that's not pathetic. And well, even though it's, you might think that you'll thank me for 16 colors. Anyway, so these little games here are the beginning and the end of what it's designed for. It's not designed for more than this or less than this. These games are what it's designed for. Some of them are quite challenging. This is a pretty. This is not an amateur game. Anyway, So where was I? So getting back to it's not. Okay, so I try to be consistent with myself. How would I do this? Naming is the most important skill a programmer has, in my opinion. You know, some people talk about literate programming. Well, the most important part of literate programming is naming. I don't. That literate shit is for pussies. That's a bunch of horse shit. They make a compiler that can reorder shit. And if you're a retard, then if you're a retarded programmer, then the compiler fixes it. I like a small compiler that does exactly what you say and doesn't get too fancy. That's what I'm telling you what my compiler does. As far as I'm concerned, the C language gets translated directly to assembly in a very straightforward fashion. And it's really obvious it's obvious if you wrote the compiler. Hello? I'll talk about that. Bye. What do I think about the Jews? There's good Jews and bad Jews. Some are so bad they cannot be eaten like figs, and every so often God has to do a Holocaust. The Jews are lucky. They get rapid evolution. In the Bible, the Jews kept fucking up, and God had to Holocaust them. So God said the world's perfectly just. So if the Jews got Holocausted, I'm going to assume they fucked up. Hello? Oh well. Okay, T0. Okay, what are we doing? Okay, so now we come down here. My auto indent, my auto indent is the consistency is next to godliness, and my rule is always use the auto indent, even though it's wrong. If you align it correctly, it looks better. Well, anyway, so the auto indent. There's only one thing better. Uncertainty is the enemy, and by just explaining to use the auto indent. There is no question. You never have to think twice. Uncertainty is the enemy. So, why is that indented? Oh, anyway. Okay, so, oh shit, oh well. You know what I'm gonna do? I'm gonna cheat. I keep core D as a mirror, and I do this all the time. I am always, I don't know how I could ever live without core D as my backup. I do it all the time. Okay, so okay. I'm trying to get this perfect. I don't uncertainty is the enemy. What's my policy on that? I don't know. That's not what I do. It's probably what I should do. Okay. That's kind of mixing. Oh well. And by the way, global variables are not efficiently laid out. When they are singular, but so it's not really a problem. I'm just telling you. I have 64 gig. In other words, each one of these global variables is probably utilizing 250 bytes for related structures. If you want to know how that goes, all the compiler information is kept so that, as a matter of fact, you have full access. If you want to go make a dynamic, so this is when the compiler makes a global variable. This is actually just the beginning. At this point, we've inherited the hash symbols. So basically, I'm just saying each global variable has I would guess 250 bytes or something. So intuitively, you would expect these to be consecutive in memory and pretty small, but these are pretty big and they're not consecutive in memory, and they're, anyway, it's not really here or there, just so you know. There's a lot of old school programmers who don't belong in the 64 gigabyte RAM world. Did you know that virtual memory is retarded? If you have 64 gigabyte, why? Do you know what happens? Have you ever encountered paging virtual memory on a modern machine? It's like, oh my God, why did it just get 500 times slower? And at that point you say, oh, this is unbearable. So if you ever do get virtual memory, in other words, there is simply no purpose for virtual memory. It's obsolete. There is no reason. If you have a mainframe with 100 users, you certainly do not have limited RAM. You have a lot of, you're going to have 64 gigabytes. Some people, now another warning I have my old mentor, he's out of touch. I made a very wise, if I was going to teach him 64-bit assembly, I made some lectures. This has the gotchas for 64-bit assembly. There's a lot of surprising things. When you push, if you push a byte, it always pushes 64 bits. If you do an operation on 32 bits, it clears, sets to 0 the upper 32. This is inconsistent with the past. In the past, operations on AL, AH, and stuff like that, those did not affect the upper bits. But this is new. It's actually good. I'm glad they did this. It's hard to explain, but so now that it's not sign extended, if you do an operation on 32 bits, it's set to 0. Now, here's what's likely to happen. Someone wants to see if my operating system is 64-bit. So what do? They do an operation on 32-bit, and guess what? It clears the upper 32-bit. And they probably think that it's not 64-bit. There are certain, it's kind of laughable that some of the obvious tests for if it's 64-bit might fail. You would guess wrong. Anyway, so FS and GS are, the segment registers are all in 64-bit, no segment registers, except FS and GS. And it's really impossible to use FS and GS. You really have to be motivated. They're RIP relative when you do an offset. So if you say 5 bytes off of FS, it's going to add RIP to the value. Now the problem is, at one location, 5 bytes plus RIP is in one spot, and at another location, 5 bytes plus RIP is another spot. So you really don't want to be, you want a 5 byte off of a register. I use them as general purpose registers for the current task and the current CPU core. My current task record. My operating system is a kayak. It's designed to crash. It's a motorcycle. If you lean over on a motorcycle, it crashes. It's that easy to crash on a motorcycle. You might say that's unsafe. How can you have a product that you just lean over and it crashes? Well, that's what a motorcycle is. If somebody changes FS, it crashes because I put the task record in FS. Don't lean over on a motorcycle. Doctor, when I do this, it hurts. Doctor says, don't do it. If SS... so this is a quiz I made that's deceptive. Anyway, so that's an example of it's RIP relative. So as it turns out, they have 16 registers, and it's kind of humorous that you know, the lower x86 has not uniform registers. Each register is different purpose. It has special purpose. Anyway, some of the quirks. Anyway, the upper 8 are coded. They inherit the coding structure of the instruction. So one of them takes an extra byte, and so does the upper 32. It's just, I wrote it in assembler and a compiler. I had to learn that, but nobody else does. So are these the same number of bytes? So so this is a fun quiz. I already covered. You can't push all the registers. There's no, in 32-bit you can push all the registers. You have to do it by hand. The TSS that has the task, they don't have room for the 16 registers, so the TSS is basically worthless. You know what's kind of unfortunate? Is it just me, or did they stop using software interrupts? Now you use syscall. When I'm in charge of Intel, we are going to make a new software interrupt that's as fast as a call, that does not change. This doesn't change anything. We're gonna make a software interrupts are 2-byte instructions. Nobody cares, do they? So the other thing is, I don't even know if I put that in here, but when you do a call to a, there's no 64-bit call, so you have to load it into a register. What I do is I put all my code in the lowest 2 gig. Anyway, I limit it to that. So where was I? We were almost done. I keep getting sidetracked. My soapbox. So this makes me really sad, because it was really small, and now it's not small. Some people have no shame. So I'm not a real fan of literate programming. You get the arrogant liberals who want to make a really complicated, slow compiler because they want to be able to make literate programs. What I say is, go with the flow and learn, go with how the machine wants to do it. Some people want to do top down instead of bottom up. The compiler wants to do it bottom up. Don't fight the compiler. Just, you got to bend with the compiler. If you're doing it like the compiler wants it, that's the right way. The right way is, don't fight. Learn to program. Now, if you have somebody who doesn't understand how the machine works, you really need to educate them at some point. It's really not good to have. Some people try to simplify for the, and all they do is make it worse. Like malloc and free. What could be harder? What could be simpler than malloc and free? Oh no, the can't understand malloc and free. We have to hide it from them. Oh my God, now you made some cluster fucked. That is retarded. Just teach the Malik and free. And life is a lot better. The little arrogant motherfuckers tried to, the liberal hearted, they wanted to oh, the can't do Malik and free. We have to conceal it from them. And now you really fucked it up. Every time you try to simplify it, it makes it 10 times worse. It's really not that hard. Malik and free, your average really can understand that. But now, whatever the fuck you replaced it with, I don't even know. I don't even know what garbage collection is. I don't know. Somehow they tried to make so the don't know what Malik and free. Oh my God. Just teach them Malik and free. If they have a bug, then at least they know what the hell they're doing. They're trying to fix a bug. I assume they think they don't free or double free. Well, that's what a programmer does, is fixes his bugs. At least he knows what he's doing. But oh my God, they try to make... Oh. Okay, so we want to, now that we're not, 5 is reasonable. 10 was good because okay, I almost always go with efficiency. Like, in this case, I'm going to go with I almost always go with efficiency. You'd be surprised. I really do it in bad taste. But that's just unbearable. Why would I create a variable just for that? Anyway. That's a naming issue. You really should when you get older, you have a certain way that you do it. I think we can make this faster. It's not... Sometimes it's... Anyway. Now what? This is the most valuable status report. I should make it part of the kernel. Oh well. So just recently I added let me tell you about some news. It is a couple weeks ago. So so how would you add this to the kernel? You would simply include it, and then when it boots, it compiles the code and places it in memory. That sounds... anyway, just recently I added run file, and what's special is what? Why didn't we get two of them? Is that my imagination? Oh yeah, of course. That's what it does. Okay, so let's say you make a standalone utility and you don't want it part of your core. What Unix does is let me explain this. This makes a file behave like a Unix file, where it's an executable and you pass arguments on the command line. If you have a Unix command, you pass arguments. Well, that's not how in TempleOS the commands are not files. In Unix, if you say dir, it's going to look for a file. In TempleOS, it's going to look in memory in the symbol table and then search Adam's symbol table. If you want to add a command like directory, then your choice is basically to compile it into the into Adam's boot code. But that's kind of distasteful. What if it's kind of a rare thing? So some of the I have some rare utilities. This one, sort headers, this doesn't have any arguments, but if you have one with arguments, now you have a problem, and that's what run files fixes. This sort headers is a utility that I only use once in a while. Actually, I use it every time I do a distribution. But anyway, it's not a problem because I don't have arguments. I can just say include it. But if you have arguments, just recently I added the run file command lets you, this has to do with mode of operation. This lets you operate like Unix, where you have a file with arguments, and that's what the command line is. This lets you operate like Unix. You can put it into your scripts. Otherwise, now if you're doing something like this, there's an if-def, or if. This is valuable. So if you're at the command line and you include this, it's going to run. If you're not at the command line, so let's say you wanted to put this into Adam's boot. Let's say you wanted to create a sort headers command in memory. You could bracket it. That's what I do with now this. Now that I think about it, I have a web log, and if somebody's running the demo. If somebody's running the demo, it does the demo files. Otherwise, you might wonder what's the big deal about run files. The big deal is it has to keep track of the last function in the file, and that's the one. The main is the last function in the file. So it's kind of a I don't even know if I documented it sufficiently. Probably not. So let's go. Let's look for run file. I have it in some of my personal code. Okay, so when I organized this, you know how you have bash RC and some of those important files? Okay, start OS is like autoexec.bat or whatever you want to call it. This is where after it boots the compiler, Atom starts compiling code. In theory, we want everything compiled just in time, ideally, but we can't. We obviously have to have the compiler ahead of time and the kernel, enough of it. It turns out about half is ahead of time, half is just in time. The Atom directory is half the operating system that's compiled by Atom just in time. Anyway, so getting back to this, do it once is kind of like, I don't know what the Unix equivalent is. This is, the other one is sort of like a kernel task. This, after it boots, it spawns some users, and one of the users at boot calls do it once. And what it's used for is, I have some scripts. If you want to transfer files in or out, normally you have to say mount, and then you go through they have some command line utilities that will mount. That, I think that's only if you buy that's only if you purchase it. Anyway, as a matter of fact, VirtualBox, the little CIA motherfuckers, just got rid of that utility. They don't want to ruin the market. Little motherfuckers. Sometimes they try to purposely fuck with me. Relax, I'm gonna have 24/7 world news coverage, and it's not gonna hurt my. Hello? Okay. He said niggerlicious. He's being a smartass, I think. Anyway, so I get my my website log file, and then when I start this, if you don't like to do it once, you're welcome to get rid of it. Oh, I didn't do it. Why did it not do it? What happened? I'm confused. Let me try that again. I didn't. I should read it. I think somebody doesn't like my do it once. What the fuck? Okay, so that worked. That was different. I'm not wrong. What the? That was different. Wait a minute, that was not different. The fuck? Sometimes the CIA wants to prevent uncertain. If they're questioning God, they don't want some hack. What the? Son of a bitch. What the fuck happened? Why was that real fast? I might have changed it. Did I change it? That's possible. I was just editing these. I changed VirtualBox. Maybe I accidentally changed. It downloaded. I know it downloaded. What the fuck is that? That's it. Oh, download. Oh. Okay. That's kind of funny. Okay. Here's the deal. I made a supplemental I made an expansion pack that you download separately, and I used to call hello? Of what? Battle tones? No. Hello? Rickroll. Oh, I think he's the expansion stuff is kind of shitty, I guess. Hello? Yeah. What? Battletoad. Oh no. Battletoads. Okay. I thought it was a smart ass. I don't know. It could still be a smart ass. Okay. Well, now. Okay, so now let's do this. That was fast. That didn't seem like it worked. But let's see if it worked. It didn't work. Son of a bitch. Oh, do you think cannot stat? I think it worked. Damn it. Hello? Battletoads. Okay. I don't know. Okay. Anyway. Let's see. I have to VM log. Oh, there it is. Change. Some kid was crying. I'm used to motherfucking CIA doing torture and shit. That's better. Okay. Now that's yesterday. It's out of date. Anyway, so what I was getting at was okay, so do it once. Hello? I can't understand you. The thing he's talking about. Am I Jewish? No, I'm not Jewish. Sort of. Anyway, so So do it once. This runs, let me explain. Okay. Hello? No, no. If you do offerings to God, he will talk. Killing animals is ridiculous. If you do songs, he likes it. If you do witty conversation. So the Jews actually did offerings to God. And that's what I do. I do offerings to God. Christians love neighbor, Jews love God. Christians love neighbor, Jews love God. Anyway, so I'm kind of like a Jew. Because the world's perfectly just. And God doesn't care if live in teepees and shit in buckets. Anyway, so make so this file is run at boot, and hello. I can't understand. Can't understand what he's saying. Anyway, if you don't like the do it once, you can change it right here. As a matter of fact, it's under your control. If you want 3 terminals, watch this. I'm going to make it boot with 4 terminals. Now we have 4 terminals. So it's that easy to change. Hello? No. Am I a Muslim? No, I'm not Muslim. I do offerings to God, and God talks. Okay, so now quit calling, and I'm going to regenerate the, let's see. Hello? I can't understand what he's saying. I think he wants to know if I'm Muslim. Why do I fast? I'm not. Actually, I haven't eaten. Not for. Okay, I'm going to. You know what? This is. 2 seconds. 1 second. 1 second's too slow. Is it? I don't like 1 second. I like 2 seconds. Okay. So is this perfect? Okay, looks perfect. Okay, so. Oh, that's what I didn't do. I have to, okay, so shut down. The log. Hello? Why? My parents have Skype or something. Whatever it is, it's a really garbage phone. Anyone out? Okay. That's no.